Well, hello and welcome back. This is Math 111, and this is section 1.6. So we're going to talk about linear inequalities. These are kind of fun. I like them. So basically, a linear inequality is very similar to an equation, but instead of having an equation, you have an inequality. A relational like that. You do it the same way as you do the other things, combining the x terms and combining the constant terms. So this is the same, just I'll show you what I'm doing here. Negative 12 halves minus 17 halves. Put that together. Okay, so now here's the important rule that you have to remember when you're solving inequalities is that if you multiply or divide, not add or subtract, but multiply or divide by a negative number, you have to flip the sign. So if I divide this by -1, then I have to change the sign from a greater than to a less than. So there are 3 ways I could write my answer. One in this inequality form right here. The other, I could graph it. So 17 halves is basically, here's 10. 17 halves goes in 8.5 times. Here's 8. 17 halves would be right here, 8.5. Open circle. This is all the numbers less than, kind of points to the direction you want to go. So yeah, this is pointing this way. Pointing this way, right? Less than 8 halves. Right? It's also, you might have heard, like when we teach it to little kids, we say alligator is eating the bigger number. So 17 halves is bigger than all the x's that we could have. It's an open circle here because we're not including the 17 halves. If there was a line under here, like this, then we would close that circle. But we're not because there isn't. The other way that we could represent our answer is all the numbers from negative infinity up to, but not including, 17 halves. Let's take a look at another couple. All right, let's so this one, let's see, how can I solve this? So many ways. Let's multiply everything by 2. And that cancel the 2 off the bottom of that fraction. Let's subtract the x's from both sides and add the 2 to both sides. Divide by a -5. Which requires we switch the sign. So this would be all the x's. Here's 1, 1/5, 1/5, 2/5 right here, 7. Oh, except for it's negative. Silly. Let's try that right. Let's do that one more time correctly. So here's -1. Here's -2. -7/5 would be right here. Open circle. Close because of that, not open. Goes down that way. This would be all the numbers from negative infinity up to and including -7/5. Bracket indicates that we're including that. All right, let's try, let's do a compound one. So this notation means that this is true and this is also true. Right. That's what that means. You can solve them separately or you can solve them together. Like, so I can take 1 away from both sides. Divide by 2. So this is true. And take 1 away from both sides. Divide by 2. This is true. Can rewrite that as this, compound into one thing, which means I am going from -3/2 to 1. Now I could have done that without breaking them up. There we go. All right, let's take more examples, and this really is kind of it for this one. Let's do one of the applications. For each cost and revenue expressions, find the break-even point and calculate the values Q for which the revenue exceeds the cost, which is what you're hoping for. So if my revenue is 5 is 10 times Q, and my cost is 8Q plus 150, when does my revenue I'm going to subtract the 8Q from both sides. Divide both sides by 2. So I have Q is greater than or equal to 75. So in this case, I would need to sell 75 units to break even and more than 75 units to make a profit. So it would be 75 even as my break-even point up to infinity to be profitable. All right. Yeah, this is a pretty light chapter compared to the beefy one from section 1.5.